Alrighty guys, so when we left off, we just solved this equation here 3 different ways and came up with the same answer. The first time we used factoring and we came up with x equals 5 or x equals -2. That was with factoring. Then we used completing the square and we got x equals 5 and x equals -2. And then we used the quadratic formula and came up with x equals 5 and x equals -2. So we're pretty sure that this quadratic formula thing is really going to work, which, if we have the song memorized, we're very cool. If we don't, I actually have it down here as a little clue there for you. So we're just going to practice using the quadratic formula and get rid of this thing here because I forgot we were going to do that. So we need to first identify what our A, B, and C are. Our A is going to be the coefficient for the x squared term. So A is going to equal 1. B is going to equal 9. And C is going to equal -22. So now it's just a plug and play thing. Just going to stick those values into here and see where it takes us. So we go x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I always do that. Okay, so when we're doing that minus 4ac, we have to pay really close attention to the signs. So we're just going to follow the order of operations, do what's under the radical first. So we'll get x equals -9 plus or minus the square root of 9 squared, which is 81, minus 4ac. So that's minus 4 times minus 22, so that's plus 88. That's the square root all over 2. Now I have a feeling that we're still going to be left over with a fraction because I'm looking at that -9 and that's saying, well, that's not going to simplify real well. But let's keep going. We've got x equals -9 plus or minus 81 plus 88. That's 169. The square root of 169 over 2. Well, I think we're okay because actually I recognize that 169 is the same thing as 13 squared. So we have x equals -9 plus or minus 13 over 2. So now we start a simplifying and we take the positive version, -9 plus 13 over 2 and -9 minus 13 over 2. So let's see, -9 plus 13, that's 4 over 2, which is the same thing as 2. And then this is -22 over 2, and that becomes -11. So we have 2 solutions, x equals 2 and x equals -11. Let's just try this -2 and see if it works because the math is just going to be easier. 2 squared is 4, plus 9 times 2 is 18, minus 22, that should equal 0. Yeah, that sure looks like it does. Well, let's do the -11 just for kicks. -11 squared is 121. Then -11 times 9 is minus 99 minus 22. So let's see. 121 minus 99, that's 22. Minus 22 minus 22 does indeed equal 0. So we are in good shape. So with just being able to identify our A, B, and C, that's going to lead us in the right direction. And being careful of the signs and being careful when we don't see a coefficient. So let's try one more. I'm going to write the A's up, the ABC up top, I think, just take up a little bit less room. Here our A is going to be 1 because there's no coefficient there. So that's the invisible 1. Our B is going to be positive 3. Oh my. Well, our 5 is in the wrong place. We need to move it back over here, which means we have to subtract it over. So C is going to be negative 5. I should have looked at it before I started assigning my variables, shouldn't I? Yeah, I should have. Sometimes I get so carried away that I forget. But this one was a pretty easy fix by subtracting 5 from both sides. So now we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now we start to simplify in. Start under the radical. Let's see, 9. Negative 4 times negative 5 is 20. All over 2. Okay. X equals 3 plus or minus the square root of 29 over 2. Guess what, guys? That's the answer. 29 is a prime number. There's no possible way we can find a square root of it. We have an irrational solution. Actually, we have two irrational solutions. We have x equals negative 3 plus the square root of 29 all over 2. And we have x equals negative 3 minus the square root of 29 all over 2. And since we don't have perfect squares under the radicals, we have irrational numbers. And it is possible to have irrational solutions to quadratics. And more often than not, we will have irrational solutions. So we just kind of introduced something new here. Let's take a look at one more. I think this one... Oh, nope. This is going to move us on to the discriminant. That's a weird word, discriminant. It kind of reminds me of the word discriminate. And it actually does. It does discriminate our solutions, and it gives us certain information. So Mr. Definition Head tells us that the discriminant basically has two functions. It tells us how many solutions a quadratic equation has, and it tells us if the solutions are rational, irrational, or non-real. Now, that's a new kind of number for us, a non-real number. They actually have a different name, and I don't want to introduce that name just yet. Okay, I will. That name is actually, it's called complex. But so far, we've been dealing with real numbers. Rational numbers are real numbers. Irrational numbers are real numbers. And if those two kinds are real numbers, then everything under them are also real numbers. So far, we've been dealing with real numbers. Now, I haven't told you what the discriminant is. And I don't think I actually have a slide here to tell us what the discriminant is. So I'm going to tell you what the discriminant is. The discriminant is everything that is under that radical. Discriminant is b squared minus 4ac. And we often call that with a capital D, just for discriminant. Okay, so our discriminant is this thing under the radical. Because that's actually pretty informative. If we have it a certain sign, then it means something. If we evaluate it to a certain type of value, it gives us something. So it's really pretty informational. So this is kind of how the discriminant talks to us. So if our discriminant is a positive perfect square, so if b squared minus 4ac is something like, I'm going to say 9, we're going to have two rational solutions. Two very pretty solutions. They could be fractions, but they're going to be very pretty. No square roots, nothing like that. We're going to have two rational solutions, kind of like we're used to. If our discriminant happens to be a positive number, but it's not a perfect square, that means we're still going to get two solutions because of that plus and minus. But our solutions are going to be irrational. And we kind of saw that in the last example, and I'll show you if we think about it, it really makes sense. If our discriminant is 0, we're going to have one solution, and it's going to be rational. And it basically means that our quadratic is a perfect square. That's kind of what it means. And then, worst case scenario, well, I wouldn't call it worst, but rare scenario is if the discriminant for AC is negative, so I'm going to just say less than 0, we are going to end up with non-real solutions, or with complex solutions. Because think about it, we're talking about with under the radical, let's see, if we're under the radical, then we're talking about plus or minus the square root of a perfect square when we put it into the quadratic formula. If we have a non-perfect square, we're talking about the plus or minus an irrational number. If we have 0 as our discriminant, we're talking about plus or minus the square root of 0, which is 0. So it's really just going to be negative b over 2a. Now, if our discriminant happens to be negative, and let's just call it negative, I don't know, negative 6, we're going to look like something like that. The positive or negative, the square root of a negative number. We've gone over this a lot. We can't take square roots of a negative number. Not and stay in the real number system. If we can take the square root of a negative number, but we go into a completely different number system, and it's just way beyond this class. So it has to deal with imaginary numbers and things like that. It's kind of really, really cool, but you'll get there. So we don't have to worry about that. So I think I'm going to stop right here. I'm going to pick it up right where we are here, and then talk some more about how we can use the discriminant to tell us this information. We're going to evaluate some discriminants and be able to say how many solutions we're going to get and what type of solutions they are.